6. In a certain chemical process, a substance A is reacts with another substance B. The masses in grams A and B represent time t seconds after the start of the process are x, y, respectively. It is given that dy dt equals to negative 0.6xy and x equals to that. T0, y equals to 70. Form a differential equation in y and t, and then solve this differential equation and obtain expression for y in terms of t. So for the first one, we know that dy dt here is equals to negative 0.6xy, while x equals to 5e to the power of negative 3t. So I can change it, negative 0.6 times 5e negative 3t times y. So equals to negative 3e negative 3ty equals to dy dt. So this is the differential equation, and then we have to solve this. So I move the y to the left side. So it's 1 over y dy dt equals to negative 3e negative 3t. And then I integrate both sides with respect to t. So I have the second type of differential equation. And then, so I have the integral 1 over y dt dy equals to negative 3 integral e negative 3t dt. The right one will be equals to e to the power of negative 3t plus c, and the left one should be equals to ln y. So we can find c, or we can change the form first. So to remove the ln, I will have y equals to e to the power of e minus 3t plus c. So this is again a e to the power of e minus 3t. And then we put the information t equals to 0, y equals to 70. So this is 70, a e to the power of e to the power of 0. That means 70 equals to a e to the power of 1. So a equals to 70 over e. So that means I will have y equals to 70 over e times e to the power of e minus 3t. So I can rewrite as 70 e to the power of e minus 3t minus 1. Yeah. This is the solution. The percentage of the initial mass of B remaining at time t is denoted by P. Find the exact value approached by P as t becomes large. When t goes to infinite, y values will become 70 e to the power of e negative infinite minus 1. So that means it's 70 e to the power of 0 minus 1. So 70 e minus 1. So this is y. What is y? Y is the mass of B. X is the mass of A. And the question, find the percentage of the initial mass of B remaining after T is denoted by P. So that means we have to find the percentage of B remaining. Now, the equation here is relating about the mass of B present. So that means the mass of B that remaining at time t. So I can simply say that this is the amount of B that's remaining at time t. So we have to find the percentage. So we have to divide it by the initial value. What is initial value? The initial value is when t equals to 0. So when t equals to 0, y is equals to 70. So to find the p, percentage of p, so we just divide 70 e minus 1 divide by the initial value 70 times 100%. So this is equals to 100% divided by E, 36.8%. Since it is looking for the exact value, so we have to answer in the exact form. It's 100 over E percent. That's it. 7. A rectangular reservoir has a horizontal base area 1000 meters squared. At time t0, it is empty, and water begins to flow into a constant rate. Okay, we have the constant rate here, meter cube per second, so this is dV over dt. 30. Flow into, so it's positive because it will be increasing. At the same time, water begins to flow out at the rate of proportional to heat. So at the same time, we will have dV over dt proportional, so I can have equals to K times square root of H, where H is the depth of the water at time t. When H equals to 1, dH dt equals to 0, 0, 2. Show that H satisfies the differential equation dH dt equals to 0.01, 3 minus square root of H. Okay, in this question, we have dH dV dt, but we have to prove dH dt. So, since this is a rectangular reservoir, and we know that the volume of this is the base area times height. So that means I can find the equation of the V. V is 1000, base area is 1000 times height. So dV dH will be equals to 1000. How do we find the dH dt? So dH dt is equals to, using the chain rule, dH dV times dV dt. So we have the dH dV is the reciprocal of this. So it's 1 over 1000 times dV dt. Now the dV dt here is about the water flow into and water flow out. So that means dV dt is equals to 30 intake and minus K square root of H for the flow out rate. So we can put it here, 30 minus K square root of H. And then we can put it into the initial condition, H equals to 1, dH dt equals to 0, 0, 2. This is dH dt. So 0, 0, 2 equals to 0, 0, 1 times 30 minus K square root of 1. So from here, I can have 0, 0, 2 divided by 0, 0, 1. 0.02 divided by 0.001. This is 20 equals to 30 minus k. So k equals to 10. So that means the equation will be dh dt equals to 0.001 times 30 minus 10 root of h. Or it can be 0.13 minus root h. Okay, shown, yeah? Next, it is given after making the substitution x equals to 3 minus root x, root h, the equation of part I become that one. Using the fact that x equals to 3 when t equals to 0, solve this differential equation, obtaining an expression t in terms of x. So we can solve this. We have x, so I have to move x to the left. So this will become x minus 3 over x dx dt equals to 0.005. So this is the third type. Integral dt, so I integral, yeah. So I will have integral x minus 3 over x dx equals to 0.005 t plus c. And then how do you integrate the left side? I can simplify 1 minus 3 over x dx equals to 0.005 t plus c. So this is x minus 3 ln x equals to 0.005 t plus c. And then we can put this one. When x equals to 3, t equals to 0. So on the right side, 0 plus c, and x equals to 3. So it's 3 minus 3 ln 3. So c is 3 minus 3 ln 3. That means the equation will be x minus 3 ln x equals to 0.005 t plus 3 minus 3 ln 3. And we have to express t in terms of x, not x in terms of t. So that means 0.005 t equals to it's x minus 3 ln x minus 3 plus 3 ln 3. Or I can simplify 0.005 t equals to x minus 3 plus 3 ln 3 minus 3 ln x. So this is x minus 3 plus 3 ln 3 over x. 0.005 t. So t equals to 200 x minus 3 plus 3 ln 3 over x. Triple I. Find the time at which the depth of water reaches 4 meters. So this is depth of water, 4 meters. This is h. Now we have to change h into x because our equation now contains x. So x equals to 3 minus root of 4. So equals to 1. So we put to the equation, it's 200. It's 1 minus 3 plus 3 ln 3 over 1. Equals to, we put to the calculator, equals to 259.2. T is in seconds. That's it. Compressed air is escaping from a container. The pressure of the air is in the container at time t is P, and the constant atmospheric pressure of the air outside the container is A. The rate of decrease of P is proportional to the square root of pressure difference. So we can start from here, the rate of decrease. So thus the differential equation connecting P and T is this one, okay. Where K is positive constant. Find in any form the general solution of this differential equation. So we can start from there. dP of dt equals to minus K square root of P minus A. Yeah, negative here because it is decreased. So we have to integral this, yeah. I have P on the left and on the right, so I have to move the P. So it's 1 over P minus A dP dt equals to minus K. So I integral both sides with respect to T. On the right side, I will have negative kt plus c. And on the left side, I will have p minus a to the power of half. And then this is 2. So p minus a to the power of half equals to half negative, yeah, kt plus c. So p minus a is equals to negative 1 over 2 kt plus c square. So P equals to A plus C minus 1 over 2 kt squared. For II, we can put the value P equals to 5A when T0. So 5A equals to A plus C minus 0 square. So that means for A equals to C square. So C equals to 2 square root of A. This is C. And then P equals to 2A when T equals to 2. So I can replace again. So it's 2A equals to A plus C, 2 square root A, minus half K times T. T is 2 square. So we can show that K equals to square root of A. So this is A equals to 2 square root A minus K square. So I remove the square. So it's square root of A equals to 2 square root A minus K. So K equals to square root of A. Shown, yeah? This is positive because A is the pressure, yeah? So it cannot be negative. Okay, the third one. Find the value of T when P equals to A. So now the equation will be equals to P, A plus 2 square root of A minus 1 over 2 square root of A T square. And then when P equals to A equals to A plus 2 root A minus half root A T square. So that means 2 root A minus half root AT equals to 0. Square equals to 0. So 2 root A minus half root AT equals to 0. So that means half root AT equals to 2 root A. So T equals to 4. Yeah. And then obtain an expression for P in terms of A and T. So for the last one, P equals to, the final answer, A plus 2 root A minus half root A T squared. This is, yeah. Nine, the number of insects in a population T days after the start of the observation is denoted by N. The variation of the number of the insect is modeled by the differential equation. It is given that N equals to 125 when T equals to 0. Solve the differential equation, obtaining the relation between N, K, and T. So we have the N dt equals to K and cos 0, 0 to T. So we have to solve this. So I have N on the right, so I have to move N to the left. So integral 1 over N dN dt equals to, this is dt, integral K cos 0, 0 to T dt. So on the left side, I will have ln M equals to, on the right side, I will have cos is integrated into sine 0, 0 to T. This is K, and then divided by 0, 0 to plus C. So that means ln M equals to 50 sine 0, 0 to T plus C. And then we can put the value N equals to 125 when T equals to 0. So ln 125 equals to 50, or this is K, sine when T equals to 0, so 0. So C is ln 125. So the equation will be ln M equals to 50K sine 0, 0 to T plus ln 125. Okay, this one. And then for the II, given also N equals to 166 when T equals to 30, find the value of K. So we put ln M is 166 equals to 50K sine 0, 0, 2 times 30 plus ln 125. So we can find K, 50K sine 0, 0 to T times 30. So this is equals to 0.36, yeah, 0.6 equals to ln 166 minus ln 125. So that means K will be equals to ln 166 over 125 divided by 50 sine 0.6. Now, in this case, the trigonometry should be in the radian. So ln 166 over 125 divided by 50 sine 0.6. So K equals to 0.010. The third one, obtain the expression for n in terms of t and find the least value of n predicted by this model. So that means ln n equals to 50 times k sine 0.02 times t plus ln 125. So we use the original value of k, yeah, multiplied by 50. So this is equals to 0.502 sine 0.02 t plus ln 125 equals to ln n. Okay, I can combine the ln minus ln 125, 0.502 sine 0.02 t. So this is ln n over 125. So that means n over 125 is e to the power of this so I can find the constant first. So e to the power of answer. So this one can be read as n over 125 equals to e to the power of 502. I can change into this 1.652 e to the power of sine 0.02 t. Since we are looking for the least value of n, so this value of n can be reached when this expression contains e to the power of sine 0.02 t is the least value. And we know that the least value of sine 0.02 t is equals to -1. So that means this will be n equals to 1.652 e to the power of -1 times 125. And this is equals to 75.97. Number 10, an underground storage tank is being filled with the liquid as shown in the diagram. Initially, the tank is empty, the time t hours, volume is V, the depth is high. It is given that V equals to 4/3 h cubed. The liquid is poured into the rate. Okay, this one is dV dt. But owing a leakage, liquid loss at the rate of proportional to the h squared. So this will be dV over dt equals to minus k, minus because of the leakage loss, yeah, k h squared because proportional. So we have to times k to make it equal. Okay, show that H satisfies this differential equation. Okay, in this case, again, we have dV dt, but we have to show in the dH dt. So using the formula V, I write here, yeah, V equals to 4/3 h cubed. So I will have dv dh equals to 4h squared. And to find the dh dt, so dh dt is dh dv times dv dt. The dv dt can be taken from these two informations. So dv dt is equals to 20 for the input and then minus with the leakage loss of k h squared. So I can put it here, dv dv is 1 over dv dh times dv dt. So this equals to 1 over 4h squared times 20 minus kh squared. So I can simplify dh dt will be equals to 5 over h squared minus k over 4. And then finding k using the information. So 4.95 equals to 5 over 1 square minus k over 4. So I have 0.05 equals to k over 4. So k equals to 0.2. So that means dh dt will be equals to 5 over h squared minus 0.2 over 4, which is 5 over h squared minus 1 over 20. Sure. That's I. For I verify that 20h squared minus over 100 minus h squared is equalized to negative 20 plus 2000 over 10 minus h 10 plus h. So in this case, I can just use the long division. So I have 20h squared divided by 100 minus h squared. So I divide it by h squared. So this is negative 20. And then I multiplied, it's positive 20h squared minus 2000. And then I minus it. I can cancel this, so I have 2000. So the result will be for 20h squared divided by 100 minus h squared is equals to negative 20 and then plus 2000 over 100 minus h squared. Or I can rewrite as 20h squared 100 minus h squared is equalized to negative 20 plus 2000 over, this is 10 plus h and then 10 minus h. So shown, yeah, verified. And for the third one, solve the differential equation and obtain the expression t in terms of h. So we solve this. So dh dt equals to 5 over h squared minus 1 over 20. So I have to move the h squared to the right side. So I have to change first the form. So I make the denominator the same. So it's 20h squared. So this is 100 minus h squared dh dt. And then I can move to the left. So it's become 20h squared over 100 minus h squared dh dt equals to 1. And then I can integrate both sides. So on the right side, I will have t plus c, but on the left side, I have this equation. So I can change it into this. So it's integral minus 20 plus 2000 over 10 minus h, and then 10 plus h. It hits. Now we have to change this form using the partial fraction. So I can, I make it here. So it's 2000 over 10 minus h, 10 plus h, become a over 10 minus h, plus b over 10 plus h. So 2000 will be equals to a times 10 plus h, plus b times 10 minus h. So for h equals to 10, I will have 2000 equals to 28. So a equals to 100. For h equals to negative 10, I have 2000 equals to 20b. So b is also 100. So I can change the values of a and b to become 100 and 100. So I can write as integral negative 20 dh plus 100 over 10 minus h, and then plus 100 over 10 plus h dh. Okay, I put integral here, so I separate here, equals to t plus c. So in this case, I will have negative 28 plus 100 of ln 10 minus h divided by negative 1 plus ln 10 plus h divided by 1 equals to t plus c. So I can simplify first. Negative 28 plus 100, and then this is ln 10 plus h over 10 minus h equals to t plus c. And then finding the c, I can put the information when h equals to 1. What is the time? There is no information of time here, but we can see from here. Initially, the tank is empty. So that means when t equals to 0, empty phi equals to 0. So that means h equals to 0. So I can put it there. So h equals to 0 plus 100 ln 1 10 over 10, yeah, equals to 0 plus c. So ln 1 is equals to 0, so c equals to 0. So that means the equation t in terms of h. So that means I will have t equals to, so the c will be gone, yeah. It's 100 ln 10 plus h over 10 minus h minus 20h. This is the final answer. That's all for this exercise. Thank you. Bye.